Hi everyone, thanks for joining in. Before we start, want to get like a quick, get to know the audience a little better. Can I get a raise of hands of how many people here are developers? Okay, everyone, that's lovely. And how many of you know about or know something about Aleo? Perfect. Okay. So today is going to be a simple workshop wherein we'll first understand what Aleo is, why was Aleo even required, and then we'll be building an application for an auction. And there's a small task towards the end of the workshop that you need to complete to be able to qualify for the reward. So let's get started. So before we get there, a little bit about me. I'm a DevRel ambassador at Aleo, and I've been in the crypto space for about 3 years. I've been an ML engineer before I transitioned into Web3. So what exactly is Aleo, right? Aleo is actually building a more secure internet. And when I say this, Aleo is essentially a private dApp supporting L1, right? And a lot of you would be thinking, like, in a world of so many L1s, what is Aleo doing? Or how does Aleo differentiate itself from the others? So today we are going to talk a lot about zero-knowledge proofs, how zero-knowledge proofs are leveraged in the Aleo ecosystem, and how you as a developer have a lot of things to do apart from just writing applications. So let's start with the basics. I know zero-knowledge proofs are not something new. They've been around for a lot of time. It's just that now their adoption in the in the Web3 space has become a little bit more practical. And that's what has led us to adopt this technology much more easily. So in simple terms, zero-knowledge proofs is just one way of proving a statement is true to another party without revealing any information that gives away any details about that statement. So to put it in very simple terms, how many of you here have played Wordle, the game by New York Times? That's a very simple example of, you could say, it's not zero-knowledge proofs, but it's a simple way that you've qualified or you've completed today's statement, but you never reveal the actual solution to it. But in real scenarios, the data, the problem statements, whatever you're trying to do, it's not going to be that simple. So you need sophisticated methods of deriving these proofs and implementing applications that leverage these proofs. But before I get started and go into the details, any of you who are still left to set up the installations for today's workshop, you can go to this link and do it. Even if you're not able to do it because of any compatibility issues or because of your OS, we do have other options of still completing the workshop today, so don't worry. But would highly suggest to have it set it up in your laptop. And if you have any issues, you can reach out to Guldeep, who's at the back, and he can help you with any installations or troubleshooting errors. So essentially, all I'm trying to say is, I know, they know, but I don't know what they know, right? Pretty confusing. So let's try to break it down as to how I can implement zero-knowledge proofs in a more mathematical manner. So there are two branches to it. You can either do it through ZK snarks, or you can do it through ZK stacks. These are two ways of implementing cryptographic proofs. Aleo as an ecosystem is based on ZK snarks. So let's break down ZK snarks a little bit. Zero knowledge is what we know. Let's understand what snarks are. Snark stands for succinct non-interactive argument. The most important aspect here being non-interactive, which means that it's a proof-based, trust-based system, which means between the party to whom I'm trying to prove a statement and the one who's verifying my statement, there's no exchange of critical information. They're only exchanging the statement which they're trying to prove. And that makes it also a succinct system, which means proofs are small and faster to verify. But how does ZK snark fit into the bigger or the larger picture of Aleo as an ecosystem? To understand that, we need to go back a little bit in the timeline. So we started with centralized system where banking was there. Banking also was digital. In order to, promote digital assets, we saw the concepts of DigiCash. There was digital gold. There was BitGold. But all of these systems were still centralized in their control. And then Bitcoin as an ecosystem came up, which provided you a way in which you could have a decentralized control over how your money operates or how your money moves. So it was an era of cryptoeconomic security. We also saw that with Bitcoin, the likes of Zcash came in, which wanted to add a layer of privacy on top of Bitcoin to make it a little bit more secure for people who were transacting money. But if we go and look forward, Ethereum is a time where money was all right. Like we could still move our money, but we didn't know what logics or what business logic I could attach with my money. So I didn't have a lot of control. So Ethereum was a time when virtual machines were supported on chain that led to the rise of smart contracts and a lot of programmability on chain. And while Ethereum was great, it had scalability issues. So this also saw the rise of other players like Cosmos, Polkadot, Neo, which were all trying to solve for different aspects of scalability in Ethereum. And if you look at it, we started to go from centralized to decentralized. We wanted to add privacy, but when we wanted to add programmability, we had to let privacy go. And that's exactly where Aleo comes in. It takes care of the decentralized aspects that we wanted to have control for, and also adds programmability. And how it does that is that it supports it through zero-knowledge execution. Zero-knowledge execution is again a concept that comes from the Zcash folks. It's a paper written by the Zcash team. Anybody who's interested should go check it out. And we'll talk about what the zero-knowledge execution here means. But a lot of the concepts that Aleo is fundamentally based on comes from the Zcash ecosystem. So in a nutshell, this is all I was trying to say, is that in the larger picture of the crypto ecosystem, this is where Aleo comes in. So it supports building private apps from the ground up. So you do not have to navigate different ecosystems when you're building a private application. And the most differentiating aspect for Aleo is that zero gas fees is needed for private transactions. And what I mean by private transactions is that as long as your computation is off-chain, you do not need to incur any gas fees. Now, what does this mean? Now, Aleo as a framework, for example, you're developing an application where your business logic is quite complex and you're dealing with probably terabytes of data. And if you look at the regular ecosystems where you would want to add zero knowledge to your application, you would still end up generating the proofs on chain for your application. What Aleo provides is you can take all of this computation off chain and have the verification of that proof done on chain. So you still have the control to save a lot of gas fees when you do the computation. And this also means that you can technically have unlimited runtime because none of the computations which is not impacting your on-chain state is done on-chain. So you can have probably like a machine learning model running off-chain and generate a proof for it, and then just run the inferences of it on-chain and verify it. I'll give you more examples to probably explain this with more code and when you actually run the workshop for it. And this is also an extension of what I just said. If you look at regular ecosystems, as the number of your executions increases, the cost of execution will actually linearly increase because all of your gas is actually proportional to the opcodes that you're going to utilize. However, here in Aleo, the cost will actually linearize. It will not be linear, but it actually flatten out, primarily because of the concept of private transactions, where you can choose to have your business logic, maximum of your computation off-chain. But how do you as developers or, folks who have probably interest in becoming a validator or a prover can get started with Aleo? So if you're a developer, there is a language that Aleo supports, which is Leo. It's a Rust-based domain-specific language, which is created specifically to support the VM that is created for writing private dApps. So you as a developer first start writing the applications in Leo as a language. It's very similar to Rust, but with a lot more abstraction of the finer details that you would have to do in Rust. Second thing is Snark VM. So Snark VM is essentially created for handling of all of the compiled instructions and all of the other processing to come up to a consensus. And then, as I said, that Aleo as an ecosystem has a concept of proof and a proof verification. So apart from validators, we also have the concept of provers. Do the job of generating these proofs for you. And once you look at the infrastructure level, you also need tools to develop real-world applications and develop dApps that end customers can use. So you also have Aleo SDK, there's Aleo Explorer, and there are a bunch of other applications. I've not written all of it, but ZPass is just one of the most popular applications. There's Puzzle Wallet, there's Avail Wallet, there's Leo Wallet that are out there, and we have quite a large ecosystem of projects that are there. And I'll also talk about how you as a developer who's looking to build on the Aleo ecosystem can get started. So let's take a step back and talk about the models a little bit. How many of you are aware of account model? Account model is something which is used in the Ethereum EVM space. Account model means that there's a global state. So anytime if you look at an address and you want to understand, say, what the balance is, there's one global state you can refer to. There's also another model called UTXO, which means unspent transaction output. How many of you are aware of UTXO? So UTXO is a model that is used primarily in the Bitcoin space. It is very similar to how your physical cash operates. For example, you have a $500 bill and you're looking to pay $350 to someone. So you're actually going to hand over the $500 bill and get the $150 back. And both of them are actual events that are happening. So if we understand UTXO, it's a bunch of different states that you'll have to actually aggregate to understand what your final balance is. So there's no concept of global state that is associated with one particular account. And that's why every time you have to, say, understand what's the total amount of money in your wallet, you'll actually have to take account of all the bills. It's very similar to that. But how does UTXO and account led to a record model? So a record model is a primitive that Aleo is built around. Now what record model does, it's similar to UTXO, but different in the form that in UTXO you can have information around who the owner is, what the balance of that account is, but not a lot of other metadata. One, records as a primitive allow you to store any metadata, any information. So it's a struct that you can customize based on what your requirement is. And what's unique about record is that every record that you create in the Aleo ecosystem gets consumed by a transition. And multiple different transitions actually make up one transaction. And then these transactions actually go into the network where they come up, the validators come to a consensus, and then the transactions get added. We'll look at how do we start writing transitions, what these transitions are, and how do you execute on-chain code. So essentially, this is actually the difference between UTXO and account. So it's more like a tree, whereas account model is generally just a global state. So balance against an address. And this is like the most important aspect of the Aleo ecosystem because this is what powers it essentially. We know you as developers can start through Leo, but you can also choose to become your own prover. Now, essentially, when you are writing an application and you want to generate proofs, for very simple applications, proof generation is simple and straightforward because you're not dealing with a lot of data. But with heavy data, your proofs can get bigger in size. So you can actually leverage third-party provers or cloud providers to generate these proofs for you against Aleo credits. And that's another thing that is supported through SnarkVM. And validators are essentially the nodes which actually come to consensus to add your transaction into the block. Now, another distinctive thing here is that in Aleo, validators work on the POS scheme, which is proof of stake. But the provers actually work on POSW, which is proof of succinct work, which means that if they're able to generate a valid proof is when they get the reward in their Aleo credits and they then qualify for being paid. But how do you actually, what's the life cycle of a program or life cycle of a transaction in the Aleo ecosystem? So essentially, let me go one step further. Once you start as a developer and you've written an application, you essentially send a response. So you have a program that you need to generate a proof of. That response actually goes to the prover, which can either be you or someone else who you have delegated to generate a proof for you. The proof then goes to the validator, where first the proof gets verified. And then the validator nodes will come to a consensus to add your transaction within the block. And then that response, which is generally a transaction ID hash, that goes back to your front end. But then let's look at what happens at both of these steps, which is the prover aspect and the validator aspect. So what happens is that as a caller request that comes in, so there's a program state where the Aleo program sits. So in Aleo, we don't have the concept of smart contracts, but we have the concepts of programs. Each program is actually going to sit in something called as a program registry, and every Aleo program is hence unique by its name because that's what defines what the program you're executing is. And every call you're making, whether it's to the prover or to the validator, is actually referenced through your Aleo program. So once I've made a call to the prover is going to take the Aleo program, compile it into Aleo instructions, and then compile it into the necessary bytecode where it can understand those machine instructions. And then the transaction goes for execution into the network. Once it has reached the network, the transaction is reaching the program registry, where between the other million programs, there's also your programs that's sitting. So the validator basically picks up your program, verifies the proof, validates it, and then comes to a consensus and then deploys your transaction. So the only difference between your traditional ecosystems in Aleo is that there's an additional step where a prover comes in to add that layer of privacy, security, which is inherently built into Aleo. So you don't need to leverage another third-party rollup or some sort of other environment to add zero knowledge to your application. And now that we know about Aleo, now's the time to start coding. So as I said, today we'll be writing a simple auction application, and we'll talk about what is the task to complete the workshop towards the end of it. So all of the code for today's workshop that you need to code along with me is there on this link. So you can go and reference it. So you don't need to write it. You can just copy it from here. For those of you who do not have a local installation which is working, you can actually go to this link, Aleo Playground. Let me show you how the interface looks like. So if you open Aleo Playground, you will be able to see all of the projects. You can also open auction from here. And you should be able to execute everything that you will be able to do in your local from Aleo Playground as well. So for the ease of it, I'll show you on the playground itself. You can also do it in VS Code, local terminal, gedit, any application that you have. So whenever you, let's actually start with a basic program before we go anywhere else. So before you start, just verify the installation by typing Leo. And if you're able to see the set of supported commands, that means that your Leo is completely and properly installed. And for folks who know about the Aleo ecosystem before and have already done the setup, please make sure you're on the testnet beta branch, which is the latest version of the testnet, because that's where you will be able to deploy. So if you see, there are a bunch of commands that are there. We will be utilizing Leo new to create a new project. And there's also a command called Leo account, which helps you create test accounts for testing your application. So it gives you a public private key and a view key. So we'll talk about what view key is as well when we look at the examples. So let's start with a new program. Let's call it Hello World, as we do in every other language. So if you look at the structure of the program, there are just two files. One is a program.json file, which is very similar to a manifest file or a package manager file, which you have in your Node projects. So it's a bunch of configs that are defined for your Aleo program to run. And then you have a main.leo file, which has all of the code that you need to execute. So let's open this project. I think I opened a different project. Just give me 1 minute. For those of you, I think, who are using VS Code, you might not see the highlighted code because you don't have the Leo extension. So you can just get it by going to the extension tabs here. And you can type Leo. The one with the black N is the extension you need for highlighting your code. So when you first open a base project, you'll see it's a simple addition program where you are trying to say that I know the sum of two numbers, but you're not saying what the sum is. Now let's start from the first line. The first line says that I'm writing a program called Hello World Brussels. So this is the unique name of your program that sits in the program registry. And under the program, you have a transition. It's not a function, it's a transition. Now transitions are what consumes your record. Transitions can also create new records. And all of the transitions is actually off-chain code. Anything you execute on-chain is done through async functions, which we'll look at a little later. Now my function is called main, and there are two arguments to it, A and B. By default, every variable in Aleo is private. So if you see B, it doesn't have an access modifier, so it will be considered private. So when you look at the transaction, you won't be able to see what the value of B is. You'll only be able to see what A is because I have chosen to let it be publicly available. And then we're just computing a simple sum where we are storing it in a variable and returning it. So let's go ahead and execute it. It's pretty straightforward. What we do when we want to execute is we say Leo, we say run, and then we write the name of the transition that we are looking to run. If you have like 10 different transitions happening, you can run each one of them, or you can also create one more transition that can sequentially call all of them. And since I'm passing two arguments, I also need to provide those arguments to my function. So it first compiles your program into Aleo instructions, and those Aleo instructions are then converted into the necessary opcodes, which then generates the output. And that's it. But in real world, you're never going to add two numbers and do anything with it. So you need to understand how to build practical applications in Aleo, and that's what we are going to do today. So if you are working on the local, you can use the same project to do it, or you can create a new project. Since it's an auction project, you can call it whatever you like. Get fancy with the names. So whatever auction underscore, and I would suggest to keep the program name short. Otherwise, when you're deploying, you might have to incur, you might need more Aleo credit. So keep the name as short as you can. So let's understand what we are trying to do in the auction. So we're creating a very simple auction application where there's an auction that is going on. And for the ease of it, there are two bidders that are trying to bid for the auction. We can have multiple as well, but for the simplicity of it, there'll be two bidders. And we're also assuming here that the auctioneer who is going to resolve the bids is fair, he's honest, and not going to be polarized towards someone, and is going to solve the auction and resolve it in a timely manner. Like whenever the bids came, they'll be solved by the time they came. So we're not going into the details of timestamps and honesty of auctioneer. And for the ease of executing this example, we will be utilizing simple accounts that we create through Aleo. So the first thing you can do to run this example is you can go to this link called provable.tools, and you can generate 3 different accounts. Why you need 3 accounts is because you need 2 bidders and 1 auctioneer, who's the one who's going to decide who the winner is. So you hit generate and you get a private key, view key, and address. So address is the public key. Your private key is one which is used to sign the messages. So you can generate 3 accounts and make a note of it. This is just to explain how to run this program. The program is there in such a way that you can run it using a shell script as well. So that's what the ops part of it is. So let's understand how do we go about creating a bid first. So I want to create a bid. Now our auction is really simple. The highest bidder wins, and we are assuming that every bid is coming in a sequential manner. So let's look at the code. You can also see this code on the playground or on the GitHub repo that's there. So what we do is we start with writing or creating a bid record. Now if you look at it, there are 4 fields to it. There's an owner, which is of type address. There's a bidder, which is of type address, amount, and whether or not he's a winner. Now let's understand the difference. Now the owner and the bidder, they're both address, but they're not the same. Now in Aleo, every record is allowed to be consumed or created by anyone who, or even like spent by anyone who owns that record. So owner field in the record bid represents who has created this record and who has the access to spend this record. However, the bidder here actually signifies who is the one bidding it for. The reason why we have added owner here is also that when I, as an auctioneer, will resolve the entire auction and decide who the winner is, I need to be able to use all of these records and come to a final decision. Now, once I have done and created my structure, I need 2 functionalities. One, to place a bid, and second, to define how is the winner decided and what price they get. So what price they get is what is the task of the workshop. So you will have to create another small functionality where you allot the price to the winner of the bid, winner of the auction. Details of that are also there. I'll show you in a while. So placing a bid. In order for us to place a bid, we need 2 things. Who the bidder is and how much my bid is. So that's the 2 arguments that I'm going to pass to my transition. Now again, it's important here to note that it's a transition, it's not a function, because we are consuming a record, or we are creating a new record here, which you can only do through a transition. If you are writing utility code, you can do that in a regular function. But if you are dealing with records, either consuming it or producing a new record, you need to use transitions. And the first thing that's important when creating a bid is to make sure that the owner, like whoever is calling this function, is actually the one who's trying to make the bid. So that's the first thing that I'm checking for. And then towards the end of it, I'm just returning a new record. Now you see that in the owner, I have added an address. This is an address that I created using the same UI. So if you're creating a new address for the auctioneer, you can update it. You can also do it more programmatically by defining it in an environment file and then picking it up from there. For simplicity, I've just added it here. So this can be any address you decide to give to the head of the auction or whoever the organizer is. And then I'm assigning the bidder, the address, the amount, and by default, is winner is turned to false. And that's about it. So let's go ahead and place a few bids and understand how are things happening. So what you can do is, so the first thing when you're placing a bid is that in your environment file, you will have to update your private key. Let me show you here. So for example, I place the first bid. So I'll have to update this private key to the first person who I'm trying to bid as. So let's pick up the first record that we had created. You can, for those who are doing this on the Aleo playground, there's a terminal that is here, and you can run all of your programs within this terminal as well. So there's a standard input-output that's available. You can actually navigate to examples, and within examples, the first program is auction. So this is the program that we are running today. Thank you. Yep. And the entire code that I just spoke about is also present here. Now, essentially, if you're having difficulty navigating these accounts or creating too many accounts, there's a list of accounts that mentioned in this run.sh file as well. So there's, just a moment. So if you look at it, there's a first bidder, there's a second bidder, and there's a auctioneer. So you can use these details as well to run this auction for now. But please make sure that every time you're calling the place bid function, you need to update your environment file to have the private key of the bidder, so that you are the one who can spend this record and create a bid for yourself. And that's exactly what this file does as well. So you go ahead and update. Basically, you are echoing it into the end file, and you essentially run place bid with the public key and then your bet. So let me execute that. I have a different private key, so let me pick public key. Let me pick that. How many of you are able to open the playground and see the function that we are working with? Okay. How many of you here have the Leo wallet already available with you? While we are looking at the function and the code, would request everybody to please get the Leo wallet, because you need it to deploy your program and also to complete the workshop. So Leo wallet is an extension that's available for your browser, and then you need to connect to Discord to get some test credits. Let me show you before we go further. So this is what the Leo wallet will look like. And once you request for test credits, you'll get 15 test credits from Discord. So that's more than enough of what we need for today's workshop. So please make sure you have that so you're able to get the deployment tested with me. And the link to the Discord is there in the README file that's there in the GitHub link. So you can go there and send like a bot command to get some faucet. I'll give 1 minute to just get that out of the way, and then we'll resume with the workshop.
Where do I get the testing files?
There's a link to the Discord for it. After that one, go to the testnet faucet channel on Discord and add your address, and you should be able to get the test credits. There's a you don't have to go to Aleo's Discord, you have to go to Leo Wallet's Discord. There's a separate link that's there in the README file. If not, I can also put it here. You got it?
Sorry, can you give me show the link of the
Discord? Yeah, sure. This is where you can go and set up an just join the Discord. Go to testnet faucet channel, and you should be able to get 15 test credits to execute today's programs. I'll just come and check. But this is the QR which has the link for the form that you need to make the submission for today's workshop. So please just scan it. It will lead you to a Google form. And we can go through this rest by. I'll just complete the end of it and then come back to you. So I had mentioned at the beginning that there's a bunch of ecosystem projects that are there within Aleo. So we have around 300 plus projects that are currently building on Aleo. A lot of those projects are tooling and infrastructure projects, but in the consumer app space, we have ZFi projects, which is DEXs, swaps, and bunch of other things around DeFi that are being built. Gaming is another field where Aleo as a chain is really helpful when you're building games. You as developers, what can you build or build? So these are some of the ideas. You can obviously get creative. You can build payment solution. You can also build data marketplaces for efficient exchange of information, and also have some access control over who gets to see your data or not. Then within the healthcare space, you can build a record management system, or you can have real world asset marketplaces, which is again a booming field right now. So tokenization is what is popular. You can add to it for probably like combine it with insurance and issue insurances on chip. You can do that with Aleo while still preserving your privacy. And in general, any marketplace application, any trading DEX, any programmable DEX sort of an application is something Aleo lets you develop without having to worry about writing circuits or writing zero knowledge proofs yourself. So Leo takes care of it for you. And there's also one more thing that I want to mention about 1 million Aleo credits. So we are running a program for testnet beta prover incentives. This program runs from July 1st to July 15th for testnet beta prover. So if you do want to become a part of the prover network, you can join in and earn your share in the pool of incentive that is there. So it's about how much you work, like how many proofs you're able to generate, you get those many credits. So it's synonymous to however much work you do. And the pool is again 1 million credits. And the more performance you give to the network, the more rewards you want. So there's an announcement that you can go to. There's details on how you can get started as a prover. If you want to get started as a prover, there's you can go to this link. There's the repository called Snark OS, which has details on what is the minimum requirement that you need to have from a system configuration perspective to get started as a user. And you as a prover, and you should be able to follow along here. And we also have grants for developers. If you're looking to build something on Aleo and effectively contribute, you can actually go to this link and submit your idea, and we review them on a rolling basis. So go ahead and submit. Would also love to see more of you in our future hackathons building something. And these are some of the links which are related to today's workshop. You can join the Telegram group for any updates. There are different channels for devs, non-devs, and events and ecosystem support partners. And that's all I have for today. This is a link for all the things related to our repo. And this is a link to a Web3 newsletter that I write. So if you're interested to learn more about how things in Web3 operate and just catch up with the speed at which operates, you can scan this QR and subscribe to it. And now I can take up issues with respect to your installation, or if you have any questions about Aleo, please feel free to ask them.
You said the task us again?
Yeah, sure. I'll figure out a way that this presentation and task can be sent to you because you have 48 hours to complete it. So you still have time to work on it and get back to it. So the task is pretty simple. I've created a new record called price. So once you have finished the auction and declared a winner, the idea is to allot the prize to the person who has won the bid. And that's all. So you have to return the record, which is updated with the prize and who the owner of the prize is.
You said 24 hours or
48 hours is what I'm aware of. But it's a simple task. You can also finish it now if you're here.
There's a few the thing works, but it's much forth Aleo trying to do something, and I cannot even get the captcha to work. So I think I'm so ignorant that I cannot even get to it. So it's getting really frustrating right now. There's another fourth.
I would suggest you to probably wait another 10 minutes here, and we can get you to deploy your first program.
Yeah, we can. Really, what?
No, we can. It takes 10 minutes. Believe me, if you have time, please stay back. Okay. I'll get to issues. Gundeep and I both can take up issues. So he's used this time to complete the workshop and probably claim the 30 USDC that's there.
Short from this gun,
sweet.